This is the example video for A10 quadratic formula. So I've got my quadratic formula up here. I'll just circle it. Okay. So first what I'll do, I'll identify what my A, B, and C are. So I'll do that right here. I know my A is the coefficient of my quadratic term. There's nothing there, or it appears that there's nothing there, so my A is going to be 1. Coefficient of my linear term is -5. And my constant is 4. So C is going to equal 4. One important thing to note when using the quadratic formula, one side of your equation has to be 0. So I've got a 0 here, so I'm all set. So I'll plug these in. So I've got x equals -b. So I've got negative in my b, which is -5, plus or minus the square root of b squared, so -5 squared, minus 4 times a, which is 1, times c, which is 4. All over 2 times a, so 2 times 1. Okay, and now I'll just simplify. So -5 is 5, plus or minus the square root of -5 squared, so -5 times -5 is positive 25, minus 4ac. So -4 times 1 is -4. -4 times 4 is -16. All over 2 times 1, which is 2. So if I keep going, I have 5 plus or minus the square root of 25 minus 16, which is 9, all over 2. So again, I'll keep going. I know the square root of 9 is 3, so I have 5 plus or minus 3 all over 2. So a lot of people feel that once they get to this point right here, they are done. Okay? You are not done at this point. We've got 2 solutions here, but we've got numbers that we can actually do out to get numerical answers. Okay? Don't leave it as some numbers over another number. Okay? Try to simplify this. Unless there's a square root that can't be simplified any further, you are not done your work. So I'll split this up into 2 different scenarios. So I'll do the plus first. We've got 5 plus 3 divided by 2. Now I'll take care of the minus. 5 minus 3 divided by 2. So 5 plus 3 is 8 divided by 2. 5 minus 3 is 2 divided by 2. 8 divided by 2 is 4. 2 divided by 2 is 1. So I know k equals 1 and 4. Okay, and we can check that, of course, by plugging both 1 and 4 back into the equation. You can also notice that this is factorable right here, and once you factor it and solve for your roots, you get the same exact answer. Okay, all right, let's move to the second one. So I'll identify my A, B, and C. A is going to be 3. B is going to be 8. And C is going to be -11. So I'll plug it into the quadratic formula. So I've got negative b, so negative 8, plus or minus the square root of b squared, so 8 squared, which is 64, minus 4 times a times c. Okay, all over 2 times a, which is 3. So if I keep simplifying, I have negative 8 plus or minus the square root of 64. Now I've got negative 4 times 3, which is 12, negative 12. Now negative 12 times negative 11, which is 132, positive, becomes plus 132. All over 2 times 3, which is 6. So if I keep simplifying, we have negative 8 plus or minus the square root of 196 all over 6. So now right here, I need to keep going. Okay, I can break down that square root of 196 further. So if we check, the square root of 196 is 14. So we have negative 8 plus or minus 14 all over 6. So I'll write out my two situations. So I'll do the plus first. We've got negative 8 plus 14 all over 6. And we have negative 8 minus 14 all over 6. So this becomes negative 8 plus 14 is 6 over 6. And negative 8 minus 14 is negative 22 over 6. Okay, so if we simplify these fractions right here, we get k equals 1, because 6 divided by 6 is 1. And simplified out, negative 22 divided by 6 can be rewritten as negative 11 over 3. So we can check these answers by plugging them back in. I encourage you to do so into our original quadratic. Or you can try it a different way. If you complete the square, you should get the same answer. If you try to factor this, you should also get the same answer. Okay, pause the video if you need more time. All right, let's keep it going. So I'll identify A, B, and C. I'll do that over here. A equals the coefficient of my quadratic term, so negative 9. B is the coefficient of my linear term, so negative 3. And C is my constant, so 21. And I've got one side of my equation equaling 0, so I know I may use the quadratic formula at this point. Okay, if it didn't equal 0, let's say there were, I don't know, a 4 over here. Okay, in order to get it to equal 0, subtract 4 from this side, subtract 4 from the other side, then it equals 0, then you may use the quadratic formula. So I'll plug everything in, so we get n equals negative b, so negative 3 becomes 3, plus or minus the square root of b squared, so negative 3 squared is going to be positive 9, minus 4 times a, which is negative 9, times c, which is 21. All over 2 times a, so 2 times negative 9. Okay, let's keep breaking it down. So we have 3 plus or minus the square root of 9. Now negative 4 times negative 9 is positive 36, and 36 times 21 equals 756. So plus 756 all over 2 times negative 9, which is negative 18. So if we continue to break it down, we have 3 plus or minus the square root of 9 plus 756, which is 765, all over negative 18. Okay, now we have to reduce this square root here, or simplify it as far as we can. So we get 3 plus or minus the square root of 756 is a decimal. Okay, so I'm going to go up here and see how I can break this down. Or 765, sorry, I apologize. So I know it's divisible by 5. So I have 5 times 153. Okay, so now I need to find factors of 153. So I know 153 is divisible by 3. So I can break this down to 5 times 3 times 51. Okay, if I keep breaking it down, I know 51 is also divisible by 3. So I've got 5 times 3 times 3 times 17. I know 17's prime, but I've got a pair here, so I can pull out a 3. So I'm left with 3 square root of 5 times 17, which is 85. So I'm going to take this 3 square root of 85 and plug it in for my square root of 765. Okay, so now I'm still not done. If I take a look here, I've got this term being divisible by 3, this term being divisible by 3, and my denominator being divisible by 3. Because all 3 of these are divisible by 3, I may simplify. Okay, so if I take a 3 out of all of them, I'm left with 1 plus or minus the square root of 85 all over negative 6. So again, you can leave your solution as this, or you can break it up into 2 solutions. So n equals 1 plus the square root of 85 over negative 6. And n also equals 1 minus the square root of 85 all over negative 6. Okay, so whether you break it up or not doesn't matter to me, as long as you know that if you do leave it as plus or minus, this represents two roots or two solutions. Okay? Another thing you might notice, way at the beginning here, our entire quadratic had a greatest common factor. Okay, because -9, -3, and +21 are all divisible by 3. Okay, so if you were to divide this entire thing by 3 or -3, well, divide it by 3, sorry, okay, and then use the quadratic formula on what was left once you took that 3 out, you should still get 1 plus or minus the square root of 85 all divided by -6. Okay, so we ended up dividing by 3 down here at the bottom. If you divide it at the beginning and dealt with smaller numbers, that's fine too. Should get the same answer. Okay, pause the video if you need more time. And let's take a look at the last example. So I'll identify A, B, and C. My A is -7. It looks like I don't have a linear term, so my B is going to be 0. And my C is +24. Okay, so if I plug these into the quadratic formula, I've got -b, so -0, which is just 0, plus or minus the square root of b squared, which is 0 squared, which is 0, minus 4 times a, which is -7, times c, which is 24. All over 2 times a, which is -7. So if I simplify, b equals, I don't really need to put the 0 there, so I've got plus or minus the square root of 0. -4 times -7 is +28, and 28 times 24 is 672. All over 2 times -7, which is -14. So if I take the square root of 672, I'm left with a decimal. Okay, so I'm going to go over here, and I'm going to break down the square root of 672. So if I do that, I know 672 is divisible by 4. So I can put 4 times 168. And I know 168 is also divisible by 4, so I can rewrite this as the square root of 4 times 4 times, sorry, not 168 anymore, 168 divided by 4 is 42. So I know I can break down 42, so let's break it down to 6 and 7. So once I break this down to 6 and 7, I know 6 will break down to 2 and 3, so I've got no pairs there, and 7 is 1 and 7. So I've got a 2, a 3, a 1, and a 7, so I'm not going to get any more pairs. But I know I can take out a 4. So I have 4 square root of 42. So I'll take this and replace it up here. So I've got plus or minus 4 square root of 42 all over -14. So I'm going to take a look at what is outside of my radical. So I've got a 4 and I've got a -14. Both of these are divisible by 2. So I know b is going to equal plus or minus 2 square root of 42 all over negative 7. Okay, and again, you can write that as just this right here, or to get rid of the plus minus, you can rewrite it as 2 over the square root of 42 all over negative 7. B equals negative 2 square root of 42 over negative 7. And again, I'm not going to be picky about this. We've got two negatives here. If you want to make those positives, that's fine with me. But if you leave them as two negatives, I'm also okay with that. So these are your roots for B.